generate over $600 billion in annual revenue. But society is changing at computer speeds. Digital media is rapidly replacing many traditionally printed products. What does all of this mean for the future of printing?
Indeed, what does this mean for the future of printing, and what does this mean for your future? Ladies and gentlemen, my name is Benny Landa, and I'm thrilled to welcome you here today, and it is so great to be back. Some of us may have met a drupa 2000 or a drupa 95, or perhaps at IPEX in 1993, when I had the privilege of unveiling the world's first digital offset color printing press as the founder of Indigo. And those of you who were there will undoubtedly have heard me say that everything that can become digital will become digital. Well, has it? Certainly there are many products that today are universally produced digitally. Photo albums, very short run label printing, transactional printing, all digital. And in the 19 years since we introduced digital printing, it has grown to 1 trillion pages a year today. However, despite all of its great success, digital printing still only nibbles around the edges of mainstream commercial printing, which is a 50 trillion page industry. So digital printing produces barely 2% of all of the pages produced. That's why we developed Nanography, a new category of digital printing to go after the 98%, the mainstream. So what is nanography? Well, as the name suggests, it's based on nanotechnology, the science of extremely, extremely small particles. How big is a nanometer? Well, I'm going to help you understand how big or how small a nanometer is. You see this golf ball? If that were 1 nanometer in diameter, then a human hair would be 4.2 kilometers in diameter, 3 times the diameter of the entire drupa messing. And you know, when you make things that small, when you make particles that small, they develop extraordinary attributes. For example, metals drop in their melting temperature. Other materials become super hard, protective abrasion resistant materials. Yet other materials become easy to be absorbed by the blood, opening up new avenues to drug delivery systems. And what we at Landa have discovered these past 10 years is that when you make pigments into nanopigments, they also develop extraordinary properties. One of them is that they become extremely efficient, powerful absorbers of light. And that is why they are at the heart of our nano ink, and nano ink is at the heart of nanoprinting technology. This technology has unbelievable characteristics, including very high speed, the broadest color gamut of any printing process, high optical density, the sharpest edges, the sharpest dots, high gloss and high gloss uniformity, can print on any paper, produces tough abrasion resistant images, is very low cost. In fact, the lowest cost of any digital printing technology, has a small footprint, as you can see, is energy efficient, has 100% environmentally friendly characteristics. And this last one is one I'm most proud of. Now I would like to show you a closer look at nanography. And ladies and gentlemen, I'm pleased to welcome you to the wonderful world of nano.
Hi there. Here dreaded drop hits, it will be like a tsunami, a tidal wave torrent that will drench the paper fibers and will mercilessly drown any nano folks like us. So we better get out of here. See, when printing processes apply ink to paper, the wet ink penetrates the paper. Now, this is true for all printing processes. In the case of inkjet, however, there's so much water in the ink that the paper becomes totally saturated. But paper and water don't mix. The paper gets swollen, deformed, and cockled. The consequence of all that is that you have to heat up all that water and paper to dry it out. And that consumes a tremendous amount of energy.
So now that we've shared some of our insights about inkjet printing, I'm sure you're all very curious to know, how do we do it? How does nanographic printing work? Well, just watch.
Nanographic printing begins with the ejection of billions of microscopic droplets of Landa nanoink onto the special image conveyor blanket. Each row of ink ejectors adds its own color of nanoink. Each droplet of nanoink lands at a precisely designated location, blending with other droplets to create the final colored ink image. As each droplet lands on the heated blanket, it begins to spread and lose its water, becoming thinner as it does so. When all of the water has been evaporated, the ink becomes an ultra-thin, dry polymeric film. Let's look again. As the nano-ink film spreads and dries, it becomes only 500 nanometers thick, the thinnest ink image of any printing process. The completed image is now ready to be transferred. Because of its unique properties, nano-ink images have the amazing ability to bond tenaciously to any paper or plastic without penetrating the substrate. Upon transfer, the nano-ink film instantaneously bonds to the paper, forming a tough, abrasion-resistant laminated layer, leaving no residual ink on the blanket. Nano-ink images can be transferred to sheets or webs of ordinary coated or uncoated paper or plastic packaging films without any kind of pretreatment. Since nano-ink images are already dry, there's no need for any kind of post-drying. So two-sided printing becomes simple, and printed goods can be immediately processed right out of the press.
Well, now that we've shared with you how it works, I'm sure you want to know what it does. So we're now going to have a close look at printed dots. We'll start with the ones you're most familiar with, which is offset printed dots. We will compare those to inkjet printed dots, and then to nano ink printed dots, In all three cases, in this example, it's on uncoated paper stock. Have a look.
Offset printed dots have poorly defined edges and non-uniform density. Inkjet printed dots are even more ragged with poor optical density. And this is nanography. Note the extraordinary edge sharpness, high image density, and uniformity. Such a startling effect deserves a more in-depth explanation. You see, as the ink penetrates the paper, much of the pigment ends up below the surface, reducing optical density and uniformity. And just as ink gets absorbed into the paper fibers, it also wicks along the paper fibers, making the edges ragged. With Landa nanographic printing, a dry ink film is applied to the paper, so there's no penetration and the edges are super sharp. Since these ultra-thin film images are literally laminated to the paper, they conform to its surface roughness right down to the topography of individual paper fibers. This accounts for nanography's extraordinary ability to match the gloss of the paper, whether coated or uncoated. Unlike conventional inks, in which the pigment particles are many hundreds of nanometers in size, Landa nano ink pigments are merely a few tens of nanometers. These nanopigments are not only super efficient absorbers of light, but they also don't scatter light. These properties give Landa nanographic printing the broadest CMYK color gamut of any printing process.
So what we've seen is that the thickness of the image very much affects the properties of the printed product. But it affects one more thing as well, the cost. The thinner the image, the less material you use to produce it, the less it costs to print. And as you can see from this image on the screen, thickness characterizes various printing processes, and commensurate with that, their printing properties and the cost of printing. Now, some have asked us, why did you develop nano ink as a water-based process and not solvent-based or perhaps UV-based? And the answer is very simple. Even if our customers could afford it, our planet can't. Therefore, nano ink is based on water. Pure, clean water. Water is not only environmentally friendly, it's plentiful, and it is cheap. But until now, there's been no alternative. And we are very proud of the fact that nano ink is water-based, because we believe that in the future, all printing must be water-based. We just cannot, as a planet, we cannot afford for it to be otherwise. Ladies and gentlemen, it is now my great pleasure to give you a brief introduction to the entire family of Landa nanographic printing presses.
The Landa nanographic press lineup comprises 3 sheet-fed presses and 3 web presses, spanning the entire range of commercial printing, packaging, and publishing applications.
in-depth, close-up look at all of our machines, we invite you to one of our product demo tours that take place between each of the theater presentations. They take place in our arcade outside. Ladies and gentlemen, the time has now come to introduce you to the stars of our show, the Landa S7 nanographic printing press and the Landa W50 nanographic printing press, and to show you some of the amazing features that these presses offer, I'm pleased to introduce you to Robin Walton, Landa evangelist par excellence. Welcome, Robert.
Thank you, Benny.
And Robin will be assisted by Shai and by Elon. Thank you. Go to it. I'll be back.
Thank you, Benny. Let's start with an inside look at the Landa S7 nanographic press, our B2 8-color perfector, capable at printing at up to 12,000 sheets per hour. Printing presses have two things in common. They come in 4 and 8-color configurations, and they all employ the most amazing user-friendly touchscreen. When it comes to particle size, smaller is better. But when it comes to touchscreens, bigger is better. And these presses come with a 3-meter-long interactive display with its man-machine interface, enabling even an untrained operator to quickly become a master. The machine controls here are on the right and on the left end of the press, allowing the press to be operated either from the feeder or the delivery end. The right-hand section here is concerned with job management, and here you can see each individual job either graphically or in a spreadsheet. And to help the operator, we have built-in intelligence, which, for example, could suggest the optimum job queuing in order to receive maximum press efficiency. And over on the left end of the press are all of the live interactive graphics that display the status updates of the different parts of the press. And also inside the press are cameras feeding over here to the monitor a live picture of what's happening with the feeder, with the press impression area, and with the delivery. Every function of the press, such as ink supply, operational status, are displayed in clear and intuitively comprehensible graphics. And now, to round things off, the incredible Landa W50 nanographic press for direct mail, trans-promo, and publishing applications, capable of printing at up to 200 meters per minute. Wow. And let's talk about productivity. These presses are a press owner's and operator's dream. Due to the high degree of automation, a single operator can manage 1, 2, 3, maybe even 4 presses at a time. And anytime the operator leaves the immediate vicinity of the press knows and automatically changes to the vital signs mode, allowing the operator to see what's happening with the press from up to 40 meters away while he's taking care of other business or maybe even taking a coffee break. He can also monitor and control the press from his remote touchpad. Cappuccinos for the press operators here, please. Print samples can be magnetically mounted on the display, and the wireless loop allows the press operator to look at what's going on the sheets, to examine, compare, and analyze the graphics. Landa Nano ink is provided in 15-kilogram containers that are easily replaceable by the operators and automatically diluted in the press using the customer's own water, saving lots of energy by not shipping water around the globe. And then the empty nano ink containers occupy minimum volume and can be recycled along with your beverage containers. And when it comes to service, there's never been a press for operators to access more easily. At the touch of a button, the display screen moves out of the way and gives the operator complete access to the entire paper path for jam removals and adjustments. And now the brains behind these beautiful presses, once again, Mr. Benny Landa.
Robin, thank you very much. Thank you. Ladies and gentlemen, as I asked you before, so what does all of this mean for the future of printing? And what does this mean for your future? Well, if you are a packaging printer, your present business is probably doing quite well, and your future also looks pretty bright. Because so long as society needs food, it will come packaged in beautifully printed containers. But what if you're in commercial printing? What are you doing? What are you producing? You are producing communication. You're producing brochures, sell sheets, magazines, newspapers, flyers, direct mail. You are producing communication. For my part, I find it hard to believe that 100 years from now, mankind will be communicating by crushing trees and smearing pigment on them. Surely digital media will by then have replaced, for the most part, printed media. But the question we all have to ask ourselves is, when is this going to happen? Well, mankind has been communicating on paper for 5,000 years and has been printing on paper for almost 600 years. Well, printed media is not going to disappear for the next many, many decades. Well, for most of us in the room and for our children, many, many decades is over the horizon. That isn't the question. The question is, how do I prosper from my business as the printing industry transitions from mechanical printing through digital printing to ultimately digital media? How do I prosper? Now you're probably thinking I'm about to say, well, you should become a digital print shop. And if that's what you're thinking, you'd be wrong. Because it is not about the 2%, it's about the 98%. And do you know where that 98% is right now? It's in your shop. And that's where the huge opportunity is. Because you already do long-run printing. And believe me, for the foreseeable future, nothing is going to challenge offset when the run lengths are millions or hundreds of thousands or even tens of thousands. This is the supreme efficient process. However, because offset requires printing plates and make-ready, the shorter the run lengths, the less profitable offset becomes. The trouble is, that's where your customers want you to go, to shorter and shorter run lengths. You already have these jobs, you just can't produce them profitably today. That's why we invented digital printing in the first place, to do the very short run lengths. And from a run length of one, digital printing is very profitable. The trouble is, with a high cost per page, the limited format sizes and limited speed, as run lengths increase, digital printing also becomes less and less profitable. And that leaves a gigantic gap where today it is really impossible to make a lot of money, but that's where your customers need you to go. That's where Landa nanographic printing comes in. We fill that gap and enable you to be profitable up to thousands of B1 sheets per run length. Thousands of B1 sheets. Ladies and gentlemen, I hope that you have heard this message clearly and that you are saying to yourself, wow, I really want one of these presses. And if you are, I invite you to meet with one of our salespeople, and we'd be very happy to sign a letter of intent with you. We will require a very modest deposit, just as a sign of seriousness, and we'd be happy to sign you up on a letter of intent. Our salespeople are waiting to talk with you. But is that enough to convince you? A demonstration at drupa? No, I don't think any of you would buy a printing press based on that, because there's two ingredients missing. Number one, you are more than likely a family-owned, relatively small business. For you to buy a printing press of any kind requires a massive investment. You might have to mortgage your home, you might have to borrow from your mother-in-law. If you make a mistake, you are jeopardizing your livelihood, and you may be jeopardizing your marriage. So the last thing you can afford to do is make a mistake. What would a mistake be? Well, you'd be buying the wrong technology. How do you know this is the right technology? I mean, go outside, everyone else will tell you, don't go that way, go this way. So that's why we have created a new strategy, sort of a new order in the printing industry. We've announced on the eve of drupa global strategic partnerships with the largest, most reliable printing companies in the world. We've announced a global strategic partnership with Heidelberg, one with Komori, one with Man Roland, and the list hasn't ended yet. Why have we done all of that? We have done that for you, because you need two additional ingredients apart from what we've shown you today. you need, number one, to know that this is the right decision. And what better way to know that it's the right decision than it's the one that everybody has embraced. Industry-wide acceptance of this as being, nanography as being the technology of next generation printing. Everybody's doing it. You could not have a more certain confidence building measure than that. But there's one more thing missing. You undoubtedly, as a small business with a huge dependence on your supplier, you undoubtedly have a relationship already with your vendor of presses. And from our experience with the customers, there's a huge level of trust between the customer and the vendor. Heidelberg customers want to buy from Heidelberg. Komori customers want to buy from Komori, and so on. And that level of trust took decades to build, and it is well deserved. I don't think anybody in this room would like to buy a press from somebody who has a monopoly who's not their favorite vendor. So therefore, these strategic alliances give you, I believe, what you now need, the confidence to know, yes, this is the right direction, and yes, I can get this from my vendor who I already trust, I'm prepared to trust him with my future, both offset printing and nanographic printing, both of which are complementary, not competitive. And therefore, that's why we offer you this choice. So, ladies and gentlemen, I hope you've enjoyed today's presentation. I have three things to say to you before I leave you. The first is, you each received a souvenir fake leather briefcase when you came in. Please don't forget it in the theater. The second thing is, before you leave the theater, please don't leave until I've prepared a little message for you. It'll appear on the screen at the end. Please don't leave until you've seen that. And lastly, I hope you all leave here saying to yourselves, apart from the fact that I hope you enjoyed the presentation, I hope you all leave here saying to yourselves, wow, I have seen the future and it is worth waiting for. Ladies and gentlemen, I thank you very much. Thank you.
Thank you.
forgive me. It's my second day of drupa, and I guess I'm a bit rusty. There's one very important thing I simply forgot to tell you in my summary, which is these presses I know are very good, impressive, and I know some of you have seen our print samples and may have liked them, but I have to tell you, people say to me, well, when will the presses be available? The presses will be available at the very earliest. The first customer shipments will only be at the end of next year. And that's why I said to you, I hope they're worth waiting for. It might not have made sense to you. Only at the end of next year, because while they may look fantastic, and you might have been impressed by the prints, have a closer look, you'll see all sorts of print defects. You will see things that still need to be fixed. And if you had a real close look inside the machines, you would also see there, these machines are not yet ready to be shipped, because in this industry, you have to ship offset quality, offset performance, and offset reliability. And that takes some time. So that's what I meant about you being patient. Our partners will be developing, manufacturing and making these machines, and you do not put Heidelberg or Comorio man rolling on a machine until it is ready and completely mature. So that's why the LOIs preserve your place in line. So again, forgive me for forgetting to tell you, and again, I hope you enjoyed the show. Thank you again. Thank you.